Alright, in these notes today we're going to be looking at how to write a quadratic in vertex form when given the vertex and a point on a graph. So let's take a look. We're going to go over some of our vocabulary first just to make sure that we remember everything that we learned so far. And first of all, what is the vertex form of a quadratic? Well, the vertex form of a quadratic function is represented by the equation f of x is equal to a times x minus h squared plus k, where h and k is the vertex of the parabola. In other words, if we had a parabola and I were to draw one on here, and I want you to draw this on your notes as well, the vertex is the point, the maximum or minimum point of the parabola. It also would be the line of symmetry, or we could cut it in half. Keep in mind, in this case, it's the minimum, and in this case right here, the vertex would be the maximum value. Now, next thing we want to look at is, what does h represent? And h, it represents the horizontal shift, which is how far it is shifted left or right from origin. And k, it represents the vertical shift, which is how far the parabola is shifted up or down from the origin. So just remember, that's your up and down. Now, next it says, when written in vertex form, what does the h and hk also represent? Well, it represents the line of symmetry. Just remember, if we have a parabola, no matter how it's shifted, say it's shifted way over here to the right, there is a point, that's the vertex, and that h value is the line of symmetry. It's the x value of where that line of symmetry would cross through. Alright, so let's go ahead and take a look at how we can do this process now. So for instance, notice it says, how do I write a quadratic in vertex form when given the vertex and a point on a graph? Well, the first thing that we're going to do is we're going to label the vertex values h and k and your point values x and y. Now this is very important with step 1, to make sure you label them so you don't mix them up. Alright, so I'm going to be using a black pen for my vertex. I'm going to label h and k just like normally that'd be x and y, but we have h and k. Imagine this is just an ordered pair. That's my vertex. And then from the point, we're going to go ahead and label it our regular x and y. So step 1 is complete. Make sure you do step 1, because if not, it will mix you up. Now, the next thing we're going to do in step 2 is to substitute the values for h, k, x, and y from the given point and solve for a using the vertex form function. Okay, let me show you what that looks like. For instance, I'm going to go ahead and write this vertex form of a function real quick. We have f of x is equal to a times x minus h squared plus k. Now what we're going to do, we know what our values are for these. Now remember, you do have to remember that f of x, really, it's just y. I want you to keep in mind that f of x just represents y. So for f of x, we know what our y value is. My y value is 12. So I'm going to put a 12 right there. I'm putting in parentheses because we're substituting the value. And then the next thing we're going to do is we're going to bring down our a. We don't have a value for that yet, but we're going to find it. Then we're going to go ahead and we're going to bring down our x value. My x value is negative 2. So I'm going to actually put in parentheses a negative 2. Now of course this is inside of the big parentheses, which is x minus my h. So for my h is negative 6. So I'm going to take that negative 6 and substitute it in. Close the parentheses, put my squared, and then I have plus k. So plus the value of k. The value of k is negative 4. Alright. Now you can see we just replaced 4 different variables. So it's very important to label them and double check that you did everything right. Y is 12. X is negative 2. H, I should have put an arrow to it. That's my H, and that's my K. h is negative 6, and k is negative 4. So I'm checking it because you know what, I got everything substituted in there. We're looking good. Now, the last thing it said to solve for a. Alright, so we want to solve for this a. So we're going to need to do the distributive property, distribute these negative signs, that positive sign, and make this a little easier to work with. So that way we can lose the parentheses. So I'm going to lose my parentheses for my 12 because a positive 1's in here. 1 times 12 is just 12. And then I have a times, I'm going to go ahead and distribute this negative sign. A negative times a negative gives me a positive. So we have negative 2 plus 6 squared. And then we have a positive times a negative. This gives me minus 4. So this is a little bit easier to deal with. I'm going to continue this process of simplifying this. So let me rewrite it as 12 equals a. Negative 2 plus 6, that's just going to give me a positive 4 squared minus 4. And if I continue this, right, 4 squared just means 4 times 4, and it's in parentheses. That's going to give me 16. So I end up with 12 is equal to a 16 minus 4. Now, some of you might be tempted at this point to subtract the 4 from the 16, but I want you to remember that a is being multiplied to 16. And order of operations says we cannot do subtraction until we take care of the multiplication. So at this point, since I'm solving for a, I'm going to go ahead and add 4 to both sides to get rid of that term. That becomes 0. I can bring this down, so I end up having a times 16 is equal to, and 12 plus 4 gives me 16. Now I hope you notice at this point the opposite of multiplying a and 16 together is dividing by 16. And then this will cancel out. 16 going to 16 one time, you end up with a is equal to 1. So all that work just to see that a was equal to 1. But it's going to make a difference because now we're going to use this a is equal to 1. Now if you're wondering, well, how can you put a in front? I just like my variable to be in front. I literally just swapped this a to the left and the 16 and 16 over to the right. I just flipped it. It's still the same thing. A is equal to 16 over 16, which is 1. And so now, since we found out what a is, we're going to start substituting some things back into our equation, and we'll have it in vertex form. So look for step 3, because we're finished with step 2. It says now rewrite your function in vertex form, substituting a, h, and k. So we're going to substitute a, we're going to substitute h, and k. So we have f of x is equal to a, which is 1. Now I could write a 1 here, but I really don't have to, and I am just going to show you just so you can see, so we can make sure you don't have any confusion here. So 1 times, and then I have x, and then I have minus my negative 6, which is my h, and that's all being squared, and then I have plus my negative 4. Now, we're almost done. We do have to do a final simplifying of this, and then we'll have our final answer. So I have f of x is equal to, and remember, if I multiply this 1 to what's inside, it doesn't change anything. Now, if I do multiply this negative 1 times the negative 6, that does change to a positive. So we end up with is x plus 6 squared, and this positive times a negative just gives us minus 4. So I'm going to box this, because this is our equation in vertex form. F of x is equal to x plus 6 squared minus 4. So it's really simplified now. And we were able to find that by doing this math. Now that a lot of times in Algebra 1, it's just going to be a positive 1. But you still need to check it because sometimes it'll be negative. And when you get into your other math classes, you may actually find coefficients that are greater than 1. So you do need to follow that process, and you need to know the process. Now, step 4, we're going to go ahead and convert this to standard form, because I do want you to practice this, and I've already showed you this before, but we do want to practice converting this back to standard form. So if I were to take this and convert it to standard form, I would go ahead and say we end up having x plus 6 times x plus 6 minus 4. And if I distribute, right, I have x times x gives me x squared, x times 6 gives me plus 6x, 6 times x gives me plus 6x, 6 times 6 gives me positive 36, and then we bring this 4 down, it's minus 4. So if we simplified it, we can combine these two terms, the positive 6 and positive 6, so I end up with x squared plus 12x, and then 36 minus 4 gives me plus 32. And that's my answer in standard form. So I have standard form down here, and I have my vertex form down here. And I guess if it helps you, I could say f of x is equal to